7, right? That's not the right lab. This is not the lab you're looking for. This is not the lab you're looking for. Oh, that's why I got it. Thank you. Okay, yeah. So we went through 7. Number 8 is just users. Number 9 is we're writing graph. We did that, right? Yeah. So 9, 10, 11, and 12. Cool. 9, 10, 11, 12. All right. So number 9, access lists. All right, on the firewall. Remember, you previously natted. So unlike a router, okay, a firewall's order of operations is reversed, meaning you nat first and then you check the access list. On a router, when packets are coming into an interface, it hits the access list first and then it does the network address translation. Okay, so what am I getting at here? On a router, you're used to writing your access lists with the public IPs. Everybody remember that from the previous lab 3? It's going to be reversed. So now that the packets are coming into the environment, right, and they're hitting the firewall, they're being translated first, and then they're going through an access list check. So that said, your ACLs need to be written, all right, where the source IP is still the source IP, no matter what, but the destination IP is not going to be the public IP, it's going to be the private IP because NAT is already happened. Does everybody understand that concept? It's just reversed from what you're used to, okay? And that's typically how all major manufacturers set up their firewalls. They NAT first and filter later.
Is there a reason for that, or is that just arbitrary?
Somewhere along the line, sometime back in the early 2000s, somebody got a wild hair and said, this is the way to do it. And it just took off from there. And, you know, all of us old timers were like, well, no, we don't want to do it that way. They're like, yeah, well, whatever. For some reason, if you have packets that are dropped in the NAT process, it takes fewer CPU cycles than if it hits the access list. It has to go all the way through the access list, or towards the bottom of the access list, gets filtered, and then, you know, it's, you know, some big academic study at some point in time determined that, or some Gartner report or some sort of testing regimen determined. So that's where we got. That's why we do that today. All right. So that said, let's look at what we have to do for number 9. So create an access list on firewall 1 as follows. Remember that you used NAT previously. Allow SMTP and POP3 to your mail server. Okay, from anywhere, because I don't specify, right? Let's open up this guy. All right, so I'm going to just create an access list. So this is traffic that's coming from where? The outside to the DMZ, right? That's where all our servers are. So I like to name access list in a source destination pattern, so I know what I'm looking at. Now, if you name your access list something different, that's okay. I'll figure it out. All right? That's not a problem. You can name your access list Sparky or Gumby or Blue. I don't care. Whatever makes you happy. All right? But from a professional standpoint, so that I know what I'm looking at in case I step off a curb and get hit by a bus, the next guy can come in and go, oh, that's what he was doing. So I'm going to do IP access dash list. I'm going to name it out because it's going from the outside to the DMZ. It is going to be an extended access list. We're permitting traffic. All right, from anywhere to the mail server. So, we have SMTP and POP3. What do we learn about that? We can do a what? An object, right? So if you do an object and you put both objects as a service in there, totally fine. You can do it this way where you do it on a per item basis, totally fine, it'll work. There's a couple different right ways you can do this. That's kind of what I'm getting at. All right. So let me just show you this here. Out, DMZ, extended, permit. You have to tell it what protocol. So SMTP is TCP. It's coming from anywhere, and it's going to the SMTP or the mail server. So that's going to be a single IP. So we're going to prep that with host. And then that mail server is the local IP 192.168.0.21. Is that right? Alright, and then what port is it going to be delivered on? SMTP is port what? Simple Mail Transfer Protocol is port 25. Okay, that's what that looks like. Now, I want to add POP3. I can write all that out again, except for the last part, because it's going to be a different port. Or, I can take the easy way out, hit the up arrow, and replace 25 with 110, because that's POP3's port. Okay? Why? Because security engineers and network engineers are lazy. That's just, it's the mantra, man. It's the mantra. Okay? The next part, oops. I'm going to let you do. So BlackBerry services from that IP to the mail server. All right. BlackBerry services are basically delivered on a couple of Microsoft ports and port 443. All right. I'm only looking for a couple of different ports there. All right. 443 being one of them. All right. Allow web and secure HTTP from the internet to your web server. So the web server's IP is 0.13. So let me show you how to do this with a service group instead. So with a service group, we have to make an object.
I think it's because you spelled object wrong the first time.
I think I did. Object dash group service. Okay. So here's where we're going to define multiple port numbers. All right. And it's going to be the web services. So I'm just going to call it web. And they're both TCP. All right, it goes into there, and now I just type in port object, EQ, and whatever the port number is. Or, hey, I have www already there. All right. Up arrow, do it again. 443. Alright. If I do a show run, I should see my object. There it is. So I have a service object called web. Alright, so from here, I just simply go back into my access list. I can do a show. I can't type tonight. Oh, out-DMZ. Okay, fine. Alright, so I can amend that with access-list, out-DMZ. Extended, permit, object group, web, the source, which is going to be from anywhere, to the destination, which will be the web server, host 192.168.0.13. Invalid object group type.
You have to do service?
Huh?
You have to do service then web? Or no?
No, it's because it's an object group, it should just pick it up. It's defined already. I hate packet transfer. I really do. Yeah. Oh, I know why. I have a network object that's already named web. Alright. If you name it something other than web, it would work. Or you can do it just the old-fashioned way, one at a time. All right. Word of the wise on letter E. DNS zone transfer, use what protocol? UDP or TCP? Zone transfers, not lookups. No, wrong. Zone transfers use TCP. Lookups use UDP. Okay? All right, so create a separate access list on Firewall 1 that allows servers on the DMZ to access the AD, okay? One thing, do not forget for both of your access lists, apply them. You apply them in global configuration mode. You don't have to go into the interface. If you go into the interface and apply them, guess what? It's still gonna work. It's just gonna be show up in your global configuration mode. Same command, access group, the name of the access list, in this case, the previous one was out-DMZ, in interface, outside. You want to put it closest to the thread. Don't forget that. You also have to do it on the other one on number 10. So in creating that access list, allow servers on the DMZ to access the AD server by IP and AD service. AD should be blocked to all other systems except the inside network. Okay? So there's a couple different things you have to do there. Access list, DMZ dash inside, extended, permit. Now your traffic coming from there, there's a couple different ways you can do this. You know that traffic coming from that DMZ is going to be pretty much from anybody. You could put any here and it'll be exactly right. You can put the network number here and that would be exactly right. You can put host in all the individual, that would be kind of convoluted. I wouldn't do it that way, but it would still be right. Okay? There's a lot of different ways that you can get this right. I'm just going to take the easy way out and put any. Because I'm expecting only traffic from the DMZ anyway coming in on that network, on that interface. All right, I'm worried about the destination. All right, permit any, actually I should say TCP first, right? Any to host 10.0.0, whatever the AD server is, right? 10.0.0.10. And then, oh, this is making me mad. And then whatever your ports are. So in this case, I'm looking at allowing by IP and AD service. So AD service, what are your services for Active Directory, guys? I don't have to do EQ because there is a range of services, 137 to 139. And there's also 445 SMB is used by AD. So if you got those two there, you're perfectly fine. You could do an explicit deny, block all other systems except the inside network. Okay, you're blocking everything there. Okay. Because you did a specific one to that destination. Because there's an implicit what at the end of an access list? An implicit denial. Okay? So that one is the only thing you need to do. Now you need to apply it. So there. Access dash group. DMZ dash inside. In interface DMZ. Okay? Number 11, you should be able to do on your own. Now, the predominance of number 11 is going to be on the routers. The firewall, for the most part, pretty locked down by default. I really don't check anything on there. There's no aux port. No. SSH, you might have to build in SSH. There's no CDP. Firewalls don't use CDP. Don't have to worry about that. Okay? Primarily, number 11, I'm going to check the routers. The ISP router, R1. Did you get the aux port locked out? Did you disable CDP? Did you do service password encryption? Things like that. Stuff. Did you enable SSH? Stuff that you've been doing the entire course. Okay? Last but not least, number 12. So, number 12, if you follow this link, there's only a certain amount of things you can do. Okay? Certain amount of things you can do. So, for the benefit of time, I'm gonna cheat. It's okay, I'm the instructor, I'm allowed. Because I have had a couple of students that have done lab 4. Thought they've done lab 4. I'm in the right class, right?
That's everyone's proof. Everyone's doing well.
Oh, I have to do it this way. I guess I'm sure they did it right. Not too hard. Ah, yeah, perfect. Perfect, perfect, perfect. Nicely done. Christopher, you here tonight? Christopher Butos? No wonder he didn't show up tonight. Alright. So, I'll keep this up here for a while, take a snapshot of it, what have you. He did a really good job on it. Okay? These are all the commands. You set up your crypto-like policy. Alright, we're making a remote access VPN. Okay? Unfortunately, the ASA and packet tracer only, you miss a couple of steps, but that's okay. This gives you kind of the gist of it. You have encryption in your policy. You have a hashing algorithm. This is a test question. This is your Diffie-Hellman group. Always go with group 2 unless you're Cisco to Cisco. I always go with group 2 anyway because I've never ran into a problem. Group 5 is more secure. It is. But group 2 is probably the preferred methodology for your keying handshake. Sets lifetime. And basically what Christopher did here is he followed all the steps in that link that's in the lab. Okay? I try not to make this hard. Alright? Alright. He enables the policy on the outside interface. He sets up a transform set with the the strongest encryption model. He sets a tunnel group. Actually, you didn't have to do a tunnel group. Group policy you have to do. You didn't have to do the clientless stuff here, that's fine. And last but not least, down here, the pre-shared key he sets. Kind of hard to see there because of this damn thing. There. The pre-shared key. Okay? So I'm looking for the pre-shared key, the group policy, the transform set, and the IKE policy. Those are the things I really check. That's it. Okay? If you got all that, full, 8 points or whatever. Not each question is worth 10 points because then it would be like 120 points. So it comes out to about 8 points per question. Kosher? Yay. Let's talk about the exam. Oops.